I'll walk you through all the files and configurations required for object detection web services and containerizing the web application. First, let's have a look into object detection.py file where we have our web service code and configuration. So this is our object detection.py file, and we are using three files, that is YOLO v3 tiny config, and you can have a look at over here, YOLO v3 tiny config and YOLO v3 tiny weights and Coco names. And the route of the web service is set to API slash object detection, and this is the post method. And the request from, the request from the client is sent to do prediction method, and the image where the image has been processed and all the objects that is in the image has been detected and returned to the client. And the web service is made threaded is equal to true to make it a multi-threading application. And now let's look into all the requirements in our requirements needed for object detection. So this is a requirements that is required, or the dependencies that is required for our application, that is Flask, NumPy, Image.io, and OpenCV. And now let's look into the Docker file. Um, this is our Docker file where we are using the Ubuntu image, and first we are updating the package manager app package manager, and we are installing the Python 3 pip and Python 3 and all the dependencies that is required for OpenCV. First, we are creating a working directory, and next we are copying all the requirements .txt file to the current working directory of the application of the container. And next we are installing, upgrading the pip, and then we are installing all the dependencies that is required for our application. Next, we are copying all the code and the configurations that is required for the application, and then this is the command that is used for running the application. Next, let's have a look at the Docker build command that is required for building the image from the Docker file. And this is the Docker command, that is Docker build -t, where -t represents the tag, and object detection is the name that is given to the tag, and dot represents the current directory of the Docker file. And let's have a look at the cluster configuration that is required for creating the kind cluster. So that is nano cluster, yeah. So this is the configuration file for creating the cluster. So first we have a control plane where the extra port mapping is set to of the container to 30275 and the host port to 80, so that the container port is exposed to host. And we also have another node, that is worker node. Now let's have a look at the worker nodes that is there in the cluster, just to make sure that the configuration file that we have used has been created properly. So from this we can see that the worker nodes have been created properly. So we have control plane and worker nodes. Now let's have a look at the configuration file that are required for deployment and services. Um, So this is the file of the deployment, and this is the file of the services. In single file which has both deployment and services. And here you can see the name of the deployment is object detection deployment, and next we have the replica set to 1. Then we have the image that has been pulled from object detection instance build tag 1, that is from the my Docker Hub registry. And we have also set the container port to 5000 and limited the CPU to 0.5 and request to 0.5. Next, we have the services, where the name of the service is set to object detection services, and it's of the type load balancer. The port of the service is 80, and the target port is 5000. That is the port of the container. And the next is the node port, that is 30275 is the port that is given to the node. Next, let's see the Nectar IP addresses and all the ports that has been exposed in the Nectar instance. So this is the Nectar IP address of my instance, and this is the port that has been exposed in the instance. Let's get back to the server again, and here let's see all the pods that is created. So yeah, before running this application or creating this video, I have scaled up the pods to 3, and you can see the 3 pods over here. So now let's go to our client and uh, let's try to send a request to the server. Yeah. So I will use this command, and this is the command that is used for sending the request from the client to the server. And this is the IP address of the client, and this is the port, and /API /object detection is the route that is given, and 4 is the multi-threading, that is the threads are set to 4. So let's send a request, and it says okay. That is because okay. So now let's run the command. It should work. Yeah, so it's getting the request from, this is sending from the request from local, and we are getting the response from the server. Perfect. So now let's have a look into the logs of the pods. So this is the command for seeing the logs, and here I've written the name of the pod. So yeah, the pod receives the request. And next, let's have a look at the next pod. So the next pod is also responding properly, and it's working. So next, yeah, the third pod, yeah, all the 3 pods are running perfectly, and this tells us that it's being load balanced.